Welcome to a video on the trigonometric function values of common angles. The goal of the video is to determine the value of the 6 trigonometric functions using reference angles and reference triangles. So the first thing we need to remember is if we have a 30, 60, 90 right triangle, the relationship among the three sides would be 1 for the shortest leg, 2 for the hypotenuse, and square root of 3 for the other leg. And of course it could be any multiple of these, but this is the most common way to represent the relationship among the three sides of a 30, 60, 90 right triangle. Now if we talk about a 45, 45 right triangle, the relationship among the three sides would be the two legs would be 1, and the hypotenuse would be the square root of 2, or any multiple. So this was covered in a previous video. If you don't know this, you might want to watch that first. Let's consider the angle 120 degrees in standard position. So we have this much rotation, or 30 degrees past 90 degrees. Here's our initial side, here's our terminal side. The 120 degree angle is sometimes called theta. Now the reference angle is formed by the terminal side of the angle and the closest part of the x-axis. So what that means is pick any point on the terminal side of the angle and draw a segment to the closest part of the x-axis, and this will form a right triangle, which is our reference triangle, and our reference angle would be this angle here, sometimes called theta prime. So the triangle formed by theta prime can be used to find the values of the 6 trigonometric function values of theta, or in this case 120 degrees. So let's take a closer look at this. Let's see if we can determine these 6 trigonometric values for 120 degrees. So go ahead and let's set this up. We know this is 120 degrees. We'll form our reference triangle by this segment here to the closest part of the x-axis. Here's our reference angle, which if this is 120, we know this would have to be 60 degrees. So if this is 60 degrees, this of course is 30 degrees. And now we know how these three sides relate to one another. This would be 1, this would be 2, and this would be the square root of 3. Now the only catch here is notice that the x-coordinate of this point would actually be -1, so we are going to have to label this as a -1. The y-coordinate would be positive square root of 3, so we leave that alone. We can use this reference triangle to find these 6 trigonometric function values. So using SOHCAHTOA, if we need to, the sine of 120 would be the ratio of the opposite side to the hypotenuse, or square root 3 over 2. Which means the cosecant of 120 degrees would be the reciprocal of this. Remember that sine theta and cosecant theta are reciprocals. We may be asked to rationalize this, which would give us 2 square root 3 over 3. The cosine of 120 degrees would be the cosine of this green angle here, which is adjacent over hypotenuse, -1/2. And since secant is a reciprocal of cosine, this would give us -2 over 1, or -2. And for the tangent of 120 degrees, it would be the ratio of the opposite side to the adjacent side, or square root 3 divided by -1, which equals negative square root 3. And the reciprocal for a cotangent of 120 degrees would be -1 square root 3. And that's it. We don't need a calculator to determine these values. And not only that, we're finding exact values, whether it's rational or irrational. Let's try another one. Let's plot 210 degrees in standard position, and then find the values of these. Here's our initial side. We'll rotate counterclockwise 210 degrees, so this would be 180, and 30 degrees more to our terminal side here. Pick any point on the terminal side, connect it to the closest part of the x-axis. This would be our reference triangle. This is our reference angle, which if this is 180, this reference angle would be 30 degrees. So we have another 30, 60, 90 right triangle. So we know that the short leg would be some multiple of 1, the hypotenuse would be some multiple of 2, and the other leg would be some multiple of the square root of 3. Again, the only condition here we have to be careful about is this coordinate here would have both a negative x and y coordinate, so the x value would have to be negative, and so would the y. So the sine of 210 degrees would be the ratio of the opposite side to the hypotenuse, or -1/2, -1/2. Cosecant would be the reciprocal, -2. The cosine of 2tan would be the ratio of the adjacent side to the hypotenuse, or -√3/2. And then the secant would be the reciprocal. If we rationalize this similar to the previous slide, we would have -2√3/3. Tangent of 2tan would be the ratio of the opposite side to the adjacent side, -1/-√3. So if we were required to rationalize this, it would be the square root of 3/3. And then, of course, the cotangent would be the reciprocal of this, which is the square root of 3. Let's try another. Now we want to plot -45 degrees. So we have initial side here, rotation clockwise of 45 degrees. Sketch the terminal side, form the reference triangle. And so this would be 45 degrees. This would also be 45 degrees, which means we should know the relationship among these three sides, and it would be 1, 1, square root 2. Again, watching the signs, now we're in the second quadrant, so the x-coordinate would be positive, but the y-coordinate would be negative, so we'll call this -1. We're ready to go. We're going to use this reference angle here to find all of these values. Sine of -45 degrees would be the ratio of the opposite side to the hypotenuse, -1/√2. Rationalizing this, we'd have -√2/2. And the cosecant would be the reciprocal of this in blue, so just -√2. Cosine would be the adjacent over the hypotenuse, a +1 over the square root of 2. Rationalized, square root 2/2. Cosecant would again be the reciprocal of the cosine ratio, square root 2. And tangent of our angle would be the opposite over the adjacent, -1/+1, which equals -1. And the reciprocal would still be -1. And it looks like I have one more, so let's go ahead and take a look at the angle 270 degrees. Here's our initial side. Now this one would be 90, 180, 270. So this is a quadrantal angle. So we're not able to form a reference triangle. But what we could think of is the unit circle. Remember that the unit circle would be if we had a circle on here where the terminal side intersected it with radius 1. So if we could determine the coordinates of this point, we could use this to find the values of these functions. And of course we could use and this would have the coordinates 0, -1. So in this case we would think of this as x, this is y. Remember it's a unit circle, so r is equal to 1. So just to refresh your memory, sine theta is equal to y/r. So here we'd have -1/1, which is equal to -1. The reciprocal is also -1. Cosine theta is x/r, which would be x/1, or just x, which is equal to 0. Remember the reciprocal of 0 would be undefined. And the tangent theta is y/x. -1/0 is also undefined. But writing this first is helpful because if you take the reciprocal of this for cotangent, we'd have 0/-1, which is equal to 0. Lastly, I'll show the unit circle, the points that would form all of the most common reference angles, meaning 30, 45, 60 in all four quadrants. So you probably should have one of these handy because it can speed up the process to find the trigonometric function values of the most common angles. We went over quite a bit of information here, but hopefully you found it helpful. Have a good day.